So welcome back. This is a sequence 2 of the course, and we will discover here a little bit of a history of the Camel language, where it comes from. Well, the origin of all this really starts from the seminal work by Sir Robin Milner, which developed a family of languages which are called ML, meta language, which is a family of statically, strongly typed functional programming languages. What you see here is actually a copy of the paper in 1978 by Robin Milner that introduces the theory of type polymorphism programming, which was at the core of the ML system. So what are the features of these languages in the ML family? Well, of course, they are functional programs, so you have first-class functionals there. This is a functional program, but it is not the only thing you find. There are some key additional ingredients. One is type inference. Okay, this vertex of the triangle here. You have polymorphic types. We'll learn more about this. They are very, very flexible and powerful types you can use. But the other point, which is even more impressive, is that types are present all along in the system. They are there to check the safety of your program, but you never need to write them. There is a fantastic type inference algorithm, the Damas binary, that actually write them for you. And finally, you have a third element, which is the definition of what are called traditionally algebraic data types. You will learn about this in the course later on. And pattern matching. These are life-saving data manipulation features that make the full combination of these three features extremely valuable for programmers. Well, let's see the history of Camel. Robin Milner started this ML language, and in 1980, Gérard Rouet at INRIA in France was leading the Projet Formel, which did some seminal work on mechanizing mathematics. And to do this seminal work, they used the first version of the ML language developed by Robin Milner and started contributing to it. For example, pattern matching was actually introduced by the people at INRIA into the ML language. And then, as it often happens, they started making a branch of their own, developing their own version to make it more fit to their particular application in mechanizing mathematics. In the middle of the 80s, they started, many people in this Projet Formel started working on the system. They were very excited about this. For example, in 1985, you have Guy Cousineau, Pierre-Louis Courriant, and Michel Monier, who designed the categorical abstract machine. It is an abstract machine that is used to execute very efficiently highly functional programs. Actually, categorical abstract machine, if you write the acronym, it is CAM, CAM. On the other side, you had ML, the language coming from Edinburgh. And so put together, that makes Camel. I mean, the first implementation of Camel was in 1987 by Eskander Suarez. So actually, Camel is not a beast with two humps crossing a desert. It is just a combination of CAM and ML. Okay? Then from 1988 to 1992, you have many people that work on the system, in particular Michel Monier and Pierre Weiss, that make it grow. And at the end, I have fond memory of this because I arrived in France and discovered these people, and it's incredible work just in these years. You had an impressive system, very sophisticated, very powerful, but also very complex and very heavy to use. You needed a professional workstation to run it on, so it was limited to some kind of very specific research work. Then, in the early 90s, there are some game-changing events that are. This is really the age of what is called Camel Light, as opposed to the old Camel, which was very heavy to use. So in 1990-1991, Xavier Leroy, who is now recognized as a leading developer of the OCaml language, the creator of the OCaml language, he really created another abstract machine, which was called Zinc, much more efficient than the CAM for general programs. And Damien Doliget writes a great memory manager. The result put together is what was called Camel Light. Small footprint, very little code, so it fit on a floppy disk, which was a big achievement for the moment, portable. You had a bytecode interpreter, so it could run on any kind of machine, and efficient. It was able to run on a basic PC of that ages, which was really more or less what you have in your pocket, even less than what you have in your pocket in your cell phone today. Now the Zinc machine and the disaster machine, which was core for the success of Camel Light, is very different from the original categorical Atman machine, but the name stayed, and so it still is called Camel. Now then things start moving up very quickly in the middle of the 90s. In 1995, Camel Special Light arrives. You have a native compiler, a rich, groundbreaking module system. Then in 1996, you have another incredible feature, objective Camel. You start to see why it is called OCaml today. Jérôme Vouillon and Didier Demy add to the system an efficient, elegant, object-oriented layer, still with type inference. That was a really major result in that moment, because before that period, everybody was convinced that it was not possible to have at the same time object orientation and polymorphic typing inference together. Actually, it was possible. It was done by these great people. In 2000, other features are arriving. Jacques Garrigue was maintaining a branch called Objective Label, and this was merged into the system, so you have polymorphic method, labeled, optional argument, polymorphic variants. And finally, many other things we are going to skip today. In 2011, a few years ago, the name was definitely changed and standardized to OCaml, but now you know where this all comes from. So over the years, OCaml gained traction, and today you have an incredible amount of wonderful users that use the rich set of unique features which are provided by the system. But it is better that you don't believe what we are going to tell to you. It's much better to listen to what the OCaml users themselves have to say about the language and why have chosen this. We will see this in the next sequence.